Imagine this. You define a user interface in TypeScript like this. Now you are pulling data from an API or a form. TypeScript gives you compile time safety, but at runtime, it vanishes. The types are gone. You have no guarantee that data actually matches your shape. That's where runtime type validation comes in. It bridges the gap between TypeScript's type system and the unpredictable world of real data, from APIs, user input, databases, you name it. So, what are your options? There's Zord, IOTS, Class Validator, and in my last video, we explored TS to Zord, a neat way to sync TypeScript types with Zord schemas. But all of these, even TS to Zord, still require writing or transforming schemas. What if we skipped all that? Today we are looking at Typia, a validator that uses your existing TypeScript types directly. No duplication, no transformations, just pure type-driven validation. And it's fast, really fast. So let's dive in. Typia is a TypeScript first library that enables runtime validation, serialization, and deserialization directly from your types. So, what does that mean? Normally, TypeScript types are erased during compilation. Typia changes that. It uses a build step to convert your types into actual runtime checks. As an example, let's make a slight modification to this code and show you how simple that is. So all we need to do is import Typia from Typia. That's all you write, just your interface, and Typia does the rest. An exception would be thrown if Typia detects a mismatch during assert. Behind the scenes, Typia uses the TypeScript compiler API to generate optimized validation code at build time, meaning zero overhead at runtime. Let's build a proper example from scratch and try it out. Note this section is optional where we create a project with TypeScript and TS Node installed and configured. Skip ahead using chapter markers on timeline if you already have a TypeScript project set up. Okay, our folder is configured to be a npm project. Let's install TypeScript and TS Node. Note TS Node allows us to execute a TypeScript file directly from command line without needing to compile with TypeScript compiler first. Okay, all left to do is configure TypeScript by creating a tsconfig file. So I'm going to say npx tsc dash dash init, and we are done. Next, we'll install Typia and see how to use it inside the project. All right, now Typia needs to hook into TypeScript compiler to analyze your types. This is done with something called a compiler transformer, basically a plugin that injects code during the build. We'll come back to what that means in a second. For now, just follow me and let's get it set up. Next, we are going to install something called tspatch. After installing tspatch, we need to run its own installer next using npx command. And I'll explain everything once we are done, so don't worry about any of this. Just keep following. For next steps, we need to edit and create some files. So for that, I'm going to open this in Visual Studio Code, which is my favorite editor. We open this using code dot. All right, as a next step, we need to go to compiler options. Here we need to enable these two lines. The experimental decorators and emit decorator metadata options allow TypeScript to include extra type information in your compiled code, and Typia needs that to do its job. Even though you won't be writing decorators yourself, Typia uses this metadata under the hood to better understand your types and generate smarter validation code. Okay, the step that follows requires us to add a plugin section at end of compiler options, and make sure you add this inside compiler options section. Alright, this plugin section tells TypeScript to use Typia's code generator during the build process. We'll talk more about how that works in just a minute. Next, we create a TS file to contain our code. And that's it. You're ready to use Typia's validation functions. Now let's first get back to what that compiler transformer part was, as I'm sure it sounded complicated. Don't worry, here's what it means. Normally when TypeScript compiles your code, It checks your types and then throws them away. They don't exist in the final JavaScript output, but Typia wants to keep those types, or rather, turn them into real working code that validates your data at runtime. To do that, Typia uses a compiler transformer, which is just a fancy way of saying it's a plugin that sits in the middle of the build process, watching your TypeScript code being compiled and injecting extra code that knows how to validate data based on types you define. Think of it like a helper that steps in during the build and says, "Hey, I see you've got a user type. Let me generate a function that checks if some data actually looks like a real user at runtime." This transformation only happens once at build time, so your runtime code stays fast and lean. In short, the transformer is the bridge that lets Typia take your TypeScript types and turn them into real runtime validators without you having to write any extra code. Before moving on, let me just add that the generated code is minimal and optimized, so it won't bloat your final bundle. So no need to worry on that part. Next, let's create a user interface, add Typia assert statement, and introduce a dummy input object that let's say we received from an API. As you might have noticed, I have introduced double quotes around age, like double quotes 23. That should have been without double quotes because our user interface expects it to be a number and it's now a string. So Typia should throw the error. Let's see if it does. And here it is. That's runtime type safety, no schema, no duplication, just the types doing the work. In an earlier video on Zord, I showed you how we define a user interface or type. We generate a Zord schema from it like this. And then how do we use this schema to parse the input? You end up maintaining both a type and a schema. Typia, on the other hand, eliminates all of this. It's just this: clean, dry, full type safe, less code, and fewer bugs. Alright, now it's time to do a proper speed test comparison between Zod and Typia. So here we are going to create a single benchmark comparing Typia and Zod on validating a million objects in an array. Right? So I took the liberty of installing Zod and creating this new file with the following code. So here I have defined an interface called payload, which takes an ID, which is number, flag a boolean, and name string. Then I created a Zod schema from it, which describes the payload object. This is followed by creating a data object, which is an array comprising of a million entries of the same type. So the structure is going to be ID equal to the index, flag true, and name test. And we are going to use the same data object to compare how Zod performs compared to Typia in a benchmark test. So let's give it a try and see for ourselves. And as you can see, Typia finished in a fraction of a time compared to Zod, 29 milliseconds compared to 250 milliseconds, thanks to its generated native code. This shows Typia winning against Zod in both speed and ease of use. We do need to discount the one-time setup in tsconfig, but after that, it's much more fun to work with. And that brings us to the limitations of Typia section. Typia isn't for everyone. It needs build setup, not plug and play like Zod. It doesn't have safe parsing like a z.safeParse, with which you can do if-else checks compared to try-catch blocks. And it has a smaller ecosystem, no out-of-box React bindings yet. So if you are a fast-moving team or prototyping, Zod might still be easier. But for production level performance and full type-driven validation, Typia is a beast. If you ever use tRPC, a library for building end-to-end TypeScript APIs, Typia works perfectly with it. You can drop Typia right into a procedure.input to validate inputs against your types. No schemas needed. It's a clean fit for full-stack TypeScript apps. I just wanted to say this one line. If you haven't used TPRC yet, no worries. I'll cover it in a future video. And that brings us to the end of this video. So should you switch to Typia? Yes, if you want maximum performance and minimal schema duplication. And yes, if your team is deep into TypeScript and value correctness, and maybe not if you want schema flexibility, partial parsing, or super low friction setup. That said, Typia is a game changer. It's fast, type safe, and clean. It's what Zod wishes it could be at scale. Let me know in comments, have you tried Typia? Would you replace Zod? And if this video helped you out, like and subscribe to the channel. Thanks for watching and happy coding.